Linacs technologies.
Hello and welcome to a new Simac tutorial where we use Simac, the Linac simulator, to learn and teach linac troubleshooting, maintenance, and operational procedures. This time we will do water tank experiments with different field sizes and observe how the crossplane and in-plane profiles change. We will examine how the absolute dose changes for smaller fields and how crossplane and in-plane profiles differ because of the scatter from the treatment head. Let's pick one of the default operating points and run a simulation. By going to the Treatment Head tab, we can see the crossplane and in-plane profiles plotted at 10 cm depth. By checking the box for Dmax, we can see the difference in absolute dose at different depths. We can change the field size by changing the x1, x2, y1 and y2 values here on the right. Let's do simulations for 5, 10, 15, 20, 30 and 40 cm field sizes. To have a 5 cm by 5 cm field size, we can choose the x and y values to be 2.5 cm. Let's run the simulation. As you can see, the beam profiles become much smaller. After each field size adjustment, we can save the machine state so that later we can do a water tank measurement with the saved state. I will name this machine state 5 cm. We can repeat this process for 10, 15, 20, 30, and 40 cm field sizes. Now that we have the machine states for all the field sizes saved, we can go to the Water Tank tab and do some water tank measurements. We can load the machine states with the desired field size and perform a water tank experiment for a given profile at a desired depth. Let's label the measurement. I will name it 5 cm cross. Then let's pick the saved machine state for 5 cm field size. Selecting the scan type to be crossplane, and for the depth, I will pick the depth to be at the Dmax of 1.5 cm for 6 MV beam. Here we can also verify that the field size is adjusted to 5 cm as intended. Let's run the experiment. Perfect, it's done. Let's go to the Review tab to verify the result. Everything looks okay. Now let's repeat this process for in-plane profiles as well. Before we move on to other field sizes, let's also do a depth dose scan to see how depth dose changes with field size. I will name this measurement 5 cm depth. In this water tank illustration on the right, you can see this red line indicating the dose measurement direction. I will repeat these steps for the rest of the field sizes. Now the fun part. Let's compare all these measurements. To do that, we go to the Compare tab. Here we see the list of our measurements. Let's pick all the crossplane measurements and compare them. We can see from the absolute dose values that the dose reduces with the field size. This is because for a given point in the projected field, the contribution to the dose from primary beam does not change. However, the contribution to the dose from scattered radiation from treatment head is different for different field sizes. We can confirm that the same thing happens with in-plane profiles. Let's unselect the crossplane profiles and select the in-plane profiles. As expected, absolute dose depends on field size. There is one notable difference between in-plane and crossplane though. If we select profiles for say 30 cm field size, we can see that they are different. This is because the X jaws and Y jaws are positioned at different distances from the target, so even though the projected primary beam is square and symmetric, the amount of scatter radiation originated from the treatment head, that reaches a given point in the water tank, is different based on where that point of interest is. Now that we have explored this, let's also have a look what is happening with the depth dose plots at different field sizes. As expected, the absolute dose is reducing with the reduction of field size. However, looking at the normalized depth dose plots, we can notice that the dose at 10 cm depth and 20 cm depth is very different. It is also reflected in this table below, where the ratio is also calculated. There we go. We used Simac to do water tank experiments for different field sizes. Now we know how absolute dose changes because of the scatter, and why the crossplane and in-plane profiles are different. To get started with Simac, create a free account at Linax.ca, to start your journey to mastering everything about linear accelerators. Thank you for joining this Simac tutorial. See you at the next one. Don't forget, your always free Linacs account gets you free Simac runs every day. Go to Linacs.ca to get started.